Okay, thank you for the introduction. My talk is about teaching Qt or using Qt for teaching. Well, I have to start. I have to say I'm sorry if I say Qt or if I pronounce it wrong, but that's how I'm used, what I'm used to, and I don't think I can switch that quickly. But my talk is about practical experiences at the University of Stuttgart. When I was kindly invited by Hanne for this talk, I had a look at the Qt homepage and at the Qt in Education course material. To be honest, I didn't even know that this existed before I was invited for the talk. And I found this nice quote over there, which says, the Qt in Education course material is developed for the purpose of teaching Qt at educational institutions. And right now there are 10 nice lectures. They're nicely structured, and they give a good overview, and I think they're nice lectures. And what I'm going to talk about is our experiences of teaching Qt or using Qt at our university. And of course, those, as I already said, those experiences are not based on those lectures. And there are two questions that I hope I will answer in this talk, which are our lectures as nicely structured as the ones which are provided, and do we actually teach Qt? Well, who is we? As was said, I'm from the University of Stuttgart, and compared to Dominic's University of Applied Science, we are quite large. So we have 20,000 students, and of course, I'm from the Department of Computer Science. What you can see over here is one of the two campuses of Stuttgart. Stuttgart has an inner city campus and a campus on the outside, and of course the computer scientists are the outsiders, so this is not in the city, it's on the outside, and this is the computer science building, which is quite new. You can see it here. We offer several degree programs in computer science, in software engineering, also in computational linguistics, information systems, and some others which are more obscure and also have only few students. And in that Department of Computer Science, I am from the Institute for Visualization and Interactive Systems. We have 4 professors. Right now there are only 3, and actually we should be 5, but I think we were 4 a few months ago, and we will be 4 again in 2 months' time, so I put 4 on there. And we have about 45 research assistants, which makes us one of the largest institutes at the Department of Computer Science at the moment. Well, I have studied software engineering, one of these courses that I have mentioned. And I've been using Qt since about 2006. Started at the university. I have used it also in the industry just as a part-time job and as an internship. And I have been now been at the Institute for Visualization and Interactive Systems since 2008. And I do my research project is in the area of navigation for blind people. Actually, that was quite funny because the techniques that I use for positioning are the same that have been mentioned before for in-depth positioning. And I also use Qt in that project, but I'm not going to talk more about that today. What I'm going to talk about is Qt in education. So what do we teach? This is an overview of our lectures. All of the lectures that our institute provides. There is one basic lecture which is called Graphical-Interactive Systems, and this is the base lecture for everything that we do, more or less. We have 3 pillars, one in computer graphics, visualization, and human-computer interaction. This is also how our institute is organized, more or less. And in the computer graphics field, we have an image synthesis, which is about rendering, ray tracing, and stuff like that. Modeling and animation, which is the Pixar lecture, so to say. Lots of movies and how to make them. And visual computing, which is sort of an advanced image synthesis lecture, and also computational photography. Then we have the visualization lecture and an advanced one on that, and a human-computer interaction lecture, which is right now dashed because the professor is not there. So at the moment, this lecture is not taking place, but the usability and interaction lecture is provided. As you can see, I have marked the ones for which we use Qt, and for this part, this is only the Graphical-Interactive Systems lecture. But that's not all that we do. We also have practical courses, which is in the computer graphics department, a graphics programming course, and in the human-computer interaction, graphical user interfaces course. And for both of them, we use Qt. And these are only for computer science students. And the software engineering students, they do so-called student projects. I'm going to talk about that later in more detail. We have seminars where the students give their own talks, and of course they also have to write a thesis at the end, and they can, if depending on the field, maybe they will use Qt in that. But going back to the lecture of Graphical-Interactive Systems, there is some basic idea behind that lecture, which is based on the groundbreaking dissertation Sketchpad by Evan Sutherland in 1963. In that dissertation, was about both computer graphics and human-computer interaction. But nowadays, those fields are often regarded separately. There are separate textbooks, separate journals, separate conferences, and also our advanced lectures are separate, as I have shown. But we think that there should be, or there will be, or already is, a coming future to the system for virtual reality, for haptic interfaces, for stuff like that. So that's the reason why we have a common basic lecture at our institute, and also, of course, because we need a basis for the advanced lectures. And Qt supports both in and graphical output. And that's the reason why we use it in accompanying exercises. And well, we use OpenGL for 3D graphics. Now, we have a little bit of a problem with that lecture, or with all of our lectures, I will have to say. Our problem is that the exercises are not mandatory, and neither are the lectures. All the students have to do is come to us at the end of the semester, write the exam, and you get the mark, and nobody will ever check if you are in the lectures, if you are in the exercises. So we have to do some motivation for the students, and well, I put a small cartoon over there where a lecturer is talking about some complicated stuff about Turing machine theory, and the student, he just thinks, what, man, I just wanted to learn how to program video games, and more often than not this is actually true. So we decided as a small motivation for the exercises, because they are not mandatory, to use a little game which is an Arkanoid clone. And this game is used as an example for some aspects of the lecture. So, for example, there's one part of the lecture is about input devices. And of course, if we talk about input devices in the lecture, these are just some example slides, which are more or less randomly taken from the lecture slides. If we talk about input devices in the lecture, handling input devices has to be done in the exercise. And Qt offers some mouse or some easy key and mouse and keyboard access. And as we use the game, this allows for some different interaction techniques. And so our students, they have to implement 5 different ways to move the paddle in the game with buttons or keyboard or mouse. So this is a screenshot of this game. As I said, this is really basic, and this is also the idea of it. There's not much code behind this game. And this is so that the students can see, oh, you can do something nice with very little code. At first, so this is kind of to say, well, try what you think you could do, and then you see it doesn't work like you have imagined. So try to make it a little better. So the first thing they should do is implement a button control. And this is a simple signal slot mechanism. There's a slot for the paddle, and the signal from the buttons get connected to that slot, and every time you click on the button, the pedal moves a bit to the right or to the left, and of course this is not playable at all. And that's also the idea. So the next thing they have to do, well, implement some keyboard control. The first thing I would say that you do is use the key press event, and for the key press event, move the pedal. But of course, what the students are going to see is that the key press event is like if you type in a key, if you press a button and hold it, and you're in Word, the letter appears. Then there's a small pause, and then the letter appears several times in a faster way. And this is also how the pedal is going to react, and that is not what they want. But of course, there is an easy solution for that. They just have to consider the key press event and the key release event, and ignore all the key press events which have is auto repeat true. So, and with that, it's already quite playable. It's okay. But we do some mouse control as an addition. The first thing they should do is just move the pedal right or left according to mouse movement. If you detect that the mouse has moved to the right, just move the pedal a bit to the right. And with this, it's not directly connected. This is done in the last step. So they have to calculate how much has the mouse been moved, and then move the pedal accordingly to the distance. Another part of the lecture is about Windows systems and widget toolkits in general. So the lecture doesn't have a focus on any special toolkit. It's just about concepts that are common to many toolkits. And again, there are some more or less randomly selected slides from our lecture. And as if, for example, as you can see, the middle one is the Qt designer, but the other ones are other GUI builders. So the lecture is not about one special toolkit. But in the exercise, again, Qt is used as an example that implements many of the concepts, or I think all of them, which are mentioned in the exercise, in the lecture, I'm sorry. And again, we're using that example. The first thing they have to do is just add some widgets. When they get this, the counters, one of the counters is missing, so they can actually see the code, which places one counter there, and then they can just add the code for the other counter, or use the designer to do it. And yeah, when they get the skeleton code, there is no layout management to all of this, so they can do some experimenting with that and see how that works. And after that, they have to subclass. Of course, this is possibly not an ideal design. I know the reason why QGraphics item is not derived from QObject, but for this, I think it was okay to do it. And they already get game item, pedal and ball, and they just implement block, which will be those blocks up there. And I think the idea is that they see they don't have to do that much. For example, the collision detection is already implemented in game items, so they don't have to do that. After that, they can add some more stuff, or do some more subclassing to have some special blocks, and then add dialogues, for example, for a high score. But all in all, this is not much. The exercise is more for whetting the appetite of the students than for actually teaching the use of a widget toolkit, because this is only so small a part of the lecture that we can't teach much more. But the idea is they see, oh, this is just so little code, not much. It was quite easy, and we hope that they will then try and work some more with it on their own. So I'm going to talk about the graphics programming course, which also uses Qt, but all in all, it's Qt is not the focus of that course. We have 5 assignments, and the first one is just some simple geometry with OpenGL, which is this picture. And second assignment is a primitive 3D modeler. They have to do to code a scene graph, picking, lightning, and GL shading language. Then there is an assignment which is about volume visualization, and a ray tracing assignment, which this picture is taken from. I've never actually given that course, so I can't talk too much about that. But yeah, the last assignment is a freestyle assignment. That means that they make their own assignment. They write it down. We say, okay, you can do that, and then they have 6 weeks to implement what they set out to do. That is quite interesting. There have been some very nice developments in that thing. For example, I've seen a very good snooker simulator, which used the NVIDIA physics simulation and other stuff. There have been really nice results in that assignment. And of course, I didn't put the sign here, but if the students want to, they can of course also use Qt in that assignment. But as I said, the course is not about 3D graphics. It's not about UI programming. It's about 3D graphics. And the only reason why we use Qt is actually because we need a UI. But the students will still learn about event-driven programming, signals and slots, menus, toolbars and shortcuts, and some mouse handling, especially for moving around the stuff on the scene. So this happens quite often. We don't set out to teach Qt, but in the end they will still learn some things about it. Well, now the graphical user interfaces programming course, which is about, of course, nearer to Qt. But then we have, again, 5 lectures, and only one of them is about Qt. And that is because we tried to do as many graphical user interfaces concepts into that exercise as possible. And there's the first assignment is about a stopwatch. As Edward said, there's always a clock or a watch. And this is done in the Windows API and in pure CN. And the idea is, if they have felt the pain of doing that, they will enjoy the other stuff. But the problem is, more often it has the effect that the students run away with the first assignment. So this is possibly not that good an idea. But once they have finished the first assignment, they will be quite happy with the second one. And again, this is a calculator. So we have those two things covered there. And this is the Qt assignment. And then we have some more interactive to-do list with which uses WPF and C#, and an assignment for an RSS client which uses JavaScript and CSS, HTML, Ajax, and one assignment which has again the idea of the students will come if something with a game is announced, and this was the reason why we introduced the Flash game. Now I'm going to have a little bit of a look at this assignment because that's the one we actually talked for here. Again, it should be about concept, and there are some things that we want to teach, some concepts that we want to teach, and for example, it's a class-based widget toolkit. When they come there, the first assignment they have done using the Windows API, there are no classes, and of course this is more or less the first thing that they should learn, and also creating new widgets by inheritance. And then there's some other things that we think the students should learn with this exercise, for example, a document object model or layout management. And Qt implements all of these concepts, and that's the reason why we use it. But then, if the student does the exercise, he will actually learn all of that stuff that I've talked about, but we hope he will also learn some more things, possibly C++ if he hasn't already. using shortcuts, menus, toolbars, the designer, the signals and slots mechanism, and all of that stuff. So the idea is, again, we look at what do we want to teach, we find it in Qt and we use it, and then we hope the students learn some more. Then we have those student projects, which are for the software engineering students. So the programming courses that I've talked about are for the computer science students. Those projects are for the software engineering students, and well, both of them should learn programming. Those two things are actually the thing at the university where the students will do most of the programming, because the other lectures often there is not that much of programming. And those projects are like a simulation of a real industry software project. These are 6 to 12 students, and it takes a full year. And sometimes there are also customers from the industry. Sometimes there is an institute which plays the customer in a way. But it's the idea is that this should be a simulation of a realistic software project, like it would be in the industry. Unlike the lectures or the programming exercises, those projects are completely new every year. So there's not some fixed assignment that the students are going to do. We just look at what do we want to do, what is an industry partner looking for, and then we decide that's the project that we're going to offer, and then the students come and implement it, or we hope they implement it. And the programming language and the toolkit and everything depends on the project and also on the students. I have seen projects where the programming language was up for choice. We just said implement this, and the students could choose whatever they wanted. Qt is often used when a C++ desktop application is developed. The screenshot that you're seeing here is from the time when I was a student. This was actually the reason why I started using Qt. We had this assignment or this project, which the idea was to implement a simulator for a state graph-based control of industrial machines and industrial robots. And this was for a department of the engineering, for an engineering department of the university, and they wanted to use the simulator for the exercises so that the students could learn how to program industry machines and robots with the state graph metaphors. And we actually in the beginning, we planned to use MFC because we didn't have much of an idea, and we just started the programming and the project, and we ran into a brick wall. We more or less saw that we have some real problems implementing the stuff that we need, and yeah, of course it is possible to do that. But we saw it will use a lot of time, and we will have to put a lot of effort into that, and we were really at a brick wall. And actually this discussion was taking place at our computer pool, and there was also a student who was doing the graphics programming course, and he was it was just by chance that he was sitting there. And he listened to our discussion, and he said, "Why don't you use Qt? That's what I do see here." And he said, "Okay, we'll have a look at that." And yeah, I the following night and the following 2 days or something like that, I looked at the documentation at Trolltech, it was back then, frantically and implemented, and 2 days later I had an early prototype of this, and I said to our colleagues, okay, we are going to use that, it's much easier. And yeah, so that's how I started Qt programming. And so to come to some conclusions, the problem that we face is that our students have not actually learned C++ when they start our lectures or our courses. They have, possibly they have, but if they have, then they have done it for their own. when at our university they teach ADA, they teach Java, but not C++. And so for us, the problem is not teaching Qt, it's more teaching C++. Because yes, and because I also think if you know C++, it's not hard to learn Qt. It's very, very easy. But the problem is learning C++. And also we want to teach concepts of graphical user interfaces, of 3D graphics, of input devices and stuff like that. And there is a good chance that those concepts can be taught with Qt. So for us, Qt is a means to an end and not the end itself. So to come back to the questions that I posed at the beginning, our lectures as nicely structured, well, as you have possibly seen now, no, they are not. They should be, really. But the problem is we just see, oh, we want to do that, then we add some stuff there and some stuff there, and there is a structure in the lecture, but not in the way that we use Qt. And do we actually teach Qt? No, and I don't think we should. Thank you. So if there are any questions, I'm ready to answer them.
I have a short question. When you use Qt in a course, not teaching Qt, so to speak, do you spend time on teaching Qt in the start, or do you teach Qt in the middle of the course, so to speak, intermixed with all the other materials?
No, the idea is not to teach Qt, just to use Qt for teaching the concepts that we want to teach. And hopefully the students will learn Qt as they go along. But we don't put any special effort into teaching Qt. And I think these are students at the university, and if we give them a lecture in Qt, it's not going to be for them. It's not going to be easier than just looking at the Nokia website or at the Qt website. So we want them to learn the concepts, and we give them the exercises, and we give them some kickstart. We do some explanation, for example, for the signals and slots mechanism, which is unknown to them, of course. But then we say, okay, here's what you have to do, and here's where you can read the documentation of Qt, and then do it.
And they manage, or do they have struggle with Qt then, or is it?
That depends. As I said, they struggle more with C++. I would say the main problem I would say with Qt is possibly the signals and slots mechanism. They are so unused to it that they try to circumnavigate it. They use all kind of, well, let's just make everything global and stuff like that, just to avoid using signals and slots because they are not used to it. Of course, that's possibly not that good, but yeah.
More questions? Yep.
Yes, how do you handle this problem that you basically should teach C++, or that your students do not know enough about C++ before using Qt? Because I see we are a school and we have the same problem. On one side, we want to make nice projects to bring the people to have fun. On the other side, they need to know C++ before we can start, and C++ and its basics is right boring. So they come from Java, they click this green button and everything starts automatically. And if you start with constructors, destructors, new and delete, they ran away from the course.
Yes.
So perhaps you have an idea how to handle this problem. Thank you.
I'm afraid I don't have a real good idea. It is a problem, yes. And I would also possibly like to introduce a C++ and Qt compact course. Right now we still offer, I think, C compact course, but this is so dated. It was invented like, I don't know, 15 years ago, and it's still taught. and this is of course not so nice, but this was from a time when they had to do these compact courses, but nowadays they don't have to, and for that reason they more or less they don't attend anyway. There's 1 or 2 students attend those compact courses, and for that reason there hasn't really been put any effort into making them better. And now what I can say is that there is some possibly there is some difference between those student projects and those programming courses. For the student projects, the approach is more or less learning by doing. There is not they can always, if they have any question, they can always come to us and ask, but the idea really is to have this project to be a real environment, and there must be a way to just learn it for university students. Later, if you're in the industry and in 20 years from now there is going to be a new programming language or whatever, something new, you don't go to a university and learn it. You just have to have the ability to teach it to you on your own. But for the graphics programming course and the graphic user interfaces course, there is we do a lot of tutoring. So those all those assignments, they run like 3 weeks, and every week we have 2 dates, fixed dates, where we are there and the students can come and ask questions. And for every problem that they run in, they should really come to us and ask the questions, and hopefully we can help them with their problems. But of course, you're correct, it would be better if there was some way of teaching C++, some more in-depth way. I have to admit, when I was in that situation, I struggled with that. I learned everything by doing, by reading Staustrup and Googling, and yes, it was not structured in any way. So you're correct. It should be better. It should possibly be more. We should possibly put more of an effort to teach C++. But the problem is, our lectures are about graphic user interfaces or graphics programming, and so we can't. We don't have the time to put that much effort into teaching C++. It's a dilemma. Yes.